Hi everybody, and welcome back to another tutorial video. In this video, I'll cover how to use the More Blocks section and why it's useful in Scratch. If you click on the tab, you'll notice that there's nothing here. This is because you have to make your own block. I'll demonstrate making a block right now. To start, just click on the Make a Block button. Now we can name our block. We can name our block whatever we want. It doesn't matter what we name it. The name has nothing to do with the actions that the block will perform. Let's just name this example. You'll notice that there's an Options tab. We'll cover this later, so don't worry about it. As soon as I clicked Make a Block, you'll notice that this Define Example appeared. Also, the block appeared in the tab, right here. Essentially, whatever we drag underneath this hat block, this block will perform. I'll show a quick example. If I drag Move 10 steps under this Define Example, when I click this example over here, it will move 10 steps. I'll draw a little diagram to help illustrate this. This diagram will help when you have more complicated blocks. For example, move 10 steps, wait 1 second, say hello. Now this isn't complicated by any means, but it's more advanced than just having one block. You'll notice that when I click this block, it moves 10 steps, wait 1 second, and then it will say hello. So basically what it's doing is this block is calling this block right over here. So as soon as I click this over here, it will run this example. Now, this block doesn't have to be on its own at all. In fact, you can make it, when space key pressed, run example. Now, the most common question that I hear is, well, this is completely silly. Why should I do this? Wouldn't it be the same thing if I just move this example out and I move this in? Well, you are absolutely correct. It does the same thing. So, why can blocks be useful? Now, the answer to this question is, blocks on their own can't do anything. They're really used for organizational purposes, and they make things in Scratch a lot easier to code, but by no means would you need blocks. In other words, you don't need blocks in order to make your program work. Your program can work just as well without blocks, but they make your program a lot easier to write and a lot simpler to follow. This is easiest to see in my latest program. This program is by far the most complicated program that I've ever written in Scratch. It's an infinite multiplayer base, so no matter how many players join, their character will appear on the screen and it will move around. Theoretically, this should be able to support an infinite amount of players. This project is shared, however, it's not fully working. I would say it's about 90% complete. I'm just ironing out the final bugs. The point is, I use defining blocks a lot in this program. You'll notice that I have 1, 2, 3, 4, 5, 6, 7 blocks. This might seem like a lot, but other programs in Scratch can have way more than this. As I said before in the video, the main reason why I use blocks is to make my program easier to follow and debug. For example, you'll notice that in this forever loop, I'm calling 4 blocks. Well, you'll say, Zach, you have 7 blocks. What happened to the rest of those blocks? Well, the answer is I'm actually running blocks inside of the definitions of other blocks. I primarily do this on this sprite. You'll see that here it says define update watchdog. You don't need to actually understand the code, but you'll see that I'm running another block inside of this block. Imagine if I didn't do any of this with the blocks. Instead of defining update watchdog here, I'd have to put all of this code inside of the forever loop that runs it. In addition, I wouldn't have to say watchdog variable to list. I would have to write all the code of watchdog variable to list, which is fairly complicated. I can find it. I probably just went right past it. Watchdog variable to list. Okay, this isn't so complicated, but a lot of the blocks could be complicated. Now, if I had a bug inside of my program, and instead of just having lots of different scripts of defining blocks, instead, if I had just one massive script, that would be a lot harder to find the bug. In addition, Defining blocks makes the program a lot easier to test. Like I said before, if I had one massive script with all of my blocks inside that one script, it would be almost impossible to test different aspects of my program. But for example, if I want to see if the clear empty slots portion of my program is working, I just click it, my program will do its thing and try and clear the empty slots, which you don't have to worry about, it's just an example. I'm just going to quickly recap everything that we've done so far. Defining a block is easy. Just go into More Blocks, click Make a Block, and name your block. The name of the block doesn't matter. Now put whatever code you want inside of this block. Let's say my code is forever, point towards mouse pointer, move 10 steps. Now when I want to start this block, all I have to do is drag it out from the More Blocks. And there we go. I have my block that works. Like I said before, you don't actually need to define a block in this case because the program is so simple. You could just use one green flag clicked, point towards mouse pointer, and you'll notice the program will do the same exact thing. The only reason why you'd use blocks would be in a bigger scale program, where organization matters and testing various aspects of the project matters. So, what exactly does this do? Well, it's very simple. All that happens is when you run this block, name of block just forwards right over here into its defined hat block. A hat block is this. It's called a hat block because it looks like a hat and it goes on top of all the scripts. Nothing can go on top of it. So what if we had something a little bit more complicated? Let's make a simple drawing block using blocks. Let's make a simple drawing program using blocks. I'll call this block reset. This reset will be the first thing that our program does. So in define reset, we're going to want the cat to go to the middle of the stage. We're also going to want it to point in direction 90. And finally, we're going to want to clear the whole stage, so all of the previous pen goes away. The last thing we might want to do is make the cat hide, so we don't see it. But we're not going to do that yet, because we're going to keep the cat shown to make sure it's doing the right things. And in our final program, we can make it hide. So the first thing our script is going to do is reset. Now, we have two ways of doing this next thing. Our next block is going to be the actual drawing script, so we'll call this draw. In draw, this is just going to be a forever loop. It's going to say forever, go to mouse pointer. Then we're going to have a simple if statement. This if statement will say, if the mouse is down, put its pen down, otherwise put the pen up. What this will do is forever, so this will continuously check. If my mouse is clicking, it will put the pen down, because if my mouse is down, I want to draw and I want pen to appear on my screen. Otherwise, I'll put the pen up. So let's try one approach and put the draw over here. So first, it will reset the program, then it will draw the program. So it's ready. Let's just draw something in full screen. That way we know the reset is working. So we have a little circle. We reset. And we already have our first bug. Look at that. This is what the bug is. We actually don't really need this go to in the beginning, because all this is doing is the cat is going to the middle, and then it's going to jump to where my mouse is, so it's creating this line. Alternatively, we could say pen up in the beginning and then have our go to, so it won't draw this line. Let's see if that fixes it. There we go. So the reset works. We can draw freely. Great. Now we can make it so the cat hides. Now, of course, this is one way to make a drawing program, but you could do it the simple way, or the simpler way, without blocks. However, look at the way I did it. So we have our initial script right here. It says when the green flag is clicked. The first thing we do is we reset, so let's just draw this line. The line is going to go directly from the reset block to its definition hat block, as I said before in the video. Next, this draw is going to go directly to its draw hat block. Now, is there a different place that I could put this draw block and have the program still work? you'll notice that this is step 1 and this is step 2. This needs to stay the same because first we have to reset the program and then we have to start the draw script. But is there a different place that I could put this draw block right over here and have the program still work? I'll give you a hint. The draw block is going to run directly after the reset block is going to run. Pause the video for a second and see if you can find out how to do this. Okay, here is the solution. I can move the draw block right underneath the reset block. So now, if I draw my little diagram again, here's what's going to happen. This reset is going to go here. And this is going to be step 1. It's going to run all of this first, and then it's going to get to the draw block right here. The draw block is going to go back to its definition. So still, this is step 1, and this would be step 2. The only difference is I'm not putting this draw block over here in the main one green flag click script. I'm putting it inside of a different block. So let's see if this still works. It does. This is using a block inside of a different block, and this is one approach to making a program. The next topic that I want to talk about is recursive blocks. Recursive is a term that you'll hear in math and also programming later on as well. Recursive functions are commonly used in other programming languages as well, like Java, C++, C, other programming languages. So let's start by making a block. Okay, let's try again. I'm going to start by making a block. I'm going to call this say, because the cat's going to say something. Also, the cat was hiding from before. Let's make him show. So this is what say is going to do. It's going to say hello, then it's going to say goodbye. So let's run say. The cat says hello, and the cat says goodbye. So what could we do to make this run forever? Well, the obvious answer is a forever loop. So we could say when green flag clicked, forever, run say. Hello, goodbye, hello, goodbye. So if I were to draw my diagram, what exactly is happening? Well, the say is going right over here, and then it's finishing. So then the say is going to run again. So this isn't step 1, this is really step infinity, because it'll happen forever, because it's in the forever loop. So what's a different way of doing this? I'm going to challenge everybody watching the video to try and figure out how to make this hello, goodbye loop run without actually using a forever loop. Well, I'm going to give the solution right now, and it's much more simple than people might think. All I have to do is drag this say right underneath here. If I draw the diagram, I also have to make it initially run. So if I draw the diagram, here's what's happening. This is going to go here. This will be step 1. After step 1, it's going to say hello, and then it's going to say goodbye. And then it's going to get to this, say. Well, like usual, all it's going to do is going to go back to its definition. So then it's going to run hello, goodbye, then it's going to run say again. Then it's going to go back to its definition. So really, like before, this is also step infinity, because it's going to keep on running and keep on running. Well, I'm sorry, it's not infinity, because it's only going to start at the second time, because first it's going to run step 1. So it's really 2 through infinity. So this is an example of my recursive function. Let's see if it works. Hello, goodbye, hello, goodbye. And it works really well. Now, you might be thinking, as you probably think for a lot of these blocks, what's the practical function in Scratch? And the answer is, as usual, it really depends on the scale of your program. You could use a forever loop, and that would work probably just the same, probably in every circumstance. But if you're using parameters, which is what we're going to talk about next, this will make a lot more sense and why you might want to use recursive functions. Also, recursive functions are used a lot more when you move on to a typing programming language. So let's talk about parameters. So what exactly is a parameter? Well, when we click Make a Block, I'm going to call this my say, because say is a good way to use a parameter for an example. So let's move to Options, and here are our options. We can either add a number input, a string input, a Boolean input, label text. Also, we have this option run without screen refresh. This doesn't really matter so much because it doesn't have to do with parameters, and also it's really simple. All it's doing is it's not going to wait for the screen to refresh or the screen to move to another frame. It's just going to keep on running the block as fast as possible. So you'll notice these pictures correspond. So what do these pictures correspond to? Well, let's see. Here's our block. I'll keep our block up here. This, if we have 1 plus 2, that's equal to 3. It's a number, and it's the same shape. Let's do a string. We may have to have... Whoops. Okay, here we are. So a string would be, for example, a block that looks like a square. Now, there are not that many blocks that actually are directly squares. This is mainly used in defining a block. But if you look, for example, this is a square because these are all strings. I'm not sure if this is specifically intended for this reason, but that's what it is. So we can add a number, a string, Boolean, or a label text. So let's just quickly talk about what all these things are if people aren't so familiar. A number is, well, it's a number. So an example would be, 1, 2, negative 1.5, your common numbers. A string is a little bit more confusing because a string can be text. So a string could be hello. And notice that I put the quotes for an exact reason. So a string could be hello. A string could also be 1. Now, in Scratch, this is a little bit more complicated because Scratch tries to make this as simple as possible, and if you put 1 in for a string, it might not even matter if it's a string input or not. It'll get converted back to 1 as a number. You shouldn't worry about this too much. It'll only be an issue if you move on to some other programming languages. But the idea is, imagine this as the number 1, the number 2, the number negative 1.5. But with strings, imagine this as you're saying hello, you're saying the number 1, you're saying 1. It's not actually the number 1, as in you can't add 2 strings. For example, if you did 1 plus 2, what does this get you? This does not get you 3. This actually gets you 1, 2. It's like using the join. This comes into play a lot more later programming. So just don't worry about this for now. Finally, a Boolean is the simplest of them all. A Boolean can either be true or false. Only one of the two. It's either true or false, and there's nothing more to it. So let's do it. Our block is going to be called say, and we're going to have our options. So if we want our character to say something, what should it be? If we say number input, our character wouldn't be able to say any text. If we say Boolean, our character would only be able to say true or false. So we're going to have to do string, because with a string, the character can say anything, a number or a letter. So let's call this what to say. Now you'll notice this define looks a little bit different. We have our define and we have say. We also have what to say. So this, even though it's a string, it looks like a number. So we're going to have to ignore that, pretend that it's square. It doesn't really matter at all. But you'll notice here in the say block, this is a square because a string goes inside of it. So if we run this as it is, it's going to say hello. But what if we drag what to say inside of hello? And then I'm going to say more blocks, say I am Scratch Cat. You're going to notice it says I am Scratch Cat. These diagrams are actually quite useful. So this is what's happening. This say block, like usual, is just going here. But this text, I am Scratch Cat, this is going into the what to say. And then this what to say over here is going into this what to say, because all of the what to says are going to be the same. It'll make more sense if I add another block. For example, think. If I say think what to say, the difference between say and think is that say is a text, say is like a comic book, Garfield saying something. Think would be with the little bubbles, him thinking something. So let's say, first you'll notice this says, I am Scratch Cat, and then it has the bubbles, I am Scratch Cat. I can put anything in here. I could put numbers, it'll do the same. The numbers, it won't be an actual number. Remember, it will be a string. So it said it and then it thinked it. This is what parameters can be used for. So we can pass something into the function. So let's try and make something a little bit more advanced. I'll call this adder. So if the block is called adder, it's going to want to take two numbers and add them together. So we're going to call this num1 and num2. So here's adder. So we're going to want it to say the response. So if I want to add num1 and num2, what will I have to put in here? I'll put this in. So it's going to say number 1 plus number 2. So now if I put adder, it has 1 and 1, the answer should be 2. If I put 5 and 2, the answer should be 7. And this is what passing through objects can be. So you have the num1, you put it there, the num2, and you put it there, and then it just adds them together. And no matter what we put in here, because remember, all this is doing is this is running here, this 5 is getting passed onto the number 1, and this 2 is getting passed into the number 2. A good point that I should make here is that the parameters here, the little circles, they correspond exactly to the order of the circles there. You'll see this block looks exactly the same. The adder goes to the adder, the 5 goes to the num1, the 2 goes to the num2. And if you had, more things, for example, if you wanted to add, text, hello, you'll notice it's the same thing. The hello goes to the hello, the 2 goes to the num2, 5 goes to the num1, adder goes to adder. So this last part is going to be a combination of all the skills that we've previously covered in the video. And it's a little bit more confusing, so if you don't fully understand it, just try and watch the video again. And honestly, it's not the most important thing that you have to know. And I'm going to talk about using recursive functions and passing in parameters into the function. So let's start. Let's say we want to have the Scratch Cat say 1, then 2, then 3, then 4, then 5, then 6, then 7. But we don't want the cat to use any variables to do that. So is this possible? Well, think for a second. See if you can come with a solution. You might have to go into the editor because this is a little more confusing. It's not so easy to do in your head. So I'm going to show the solution right now. So let's just call this counter. Second time I did that today. So let's just call this counter. We go into the options, we're going to have a parameter. So I'm going to call this starting number. So here's our block, starting number. This is what we're going to do. I'll explain this after. First, I'm just going to write this out. So it's going to do say starting number. My mistake, starting number was not the best name for this block. A better name probably would have been number. This doesn't make a difference because remember, as I said, the name of the block doesn't make a difference. The name of the parameter doesn't make a difference either. Okay. Sorry about this. So number. Now I'll move number here. So if we just test this as it is, it should say 1. Perfect. So how do we get this 1 to become a 2? Well, we use recursive as we talked about it before. So we'll move this counter in here, and then we'll add our little plus, and it's going to say the number plus 1. So let's see if this works. 1, 2, 3. So let's draw our diagram again for this. So this counter is going to run counter, as usual. 1 is going to get passed through to the number. So then it's going to say 1 the first time, because the order is it goes here. Then the next thing is it's going to go and run counter again. Except remember, the number is 1 because this goes here and it continues to 1. So it's going to run counter 1, and then it's going to do plus 1, which is equal to 2, obviously. So let's erase everything. Now you're going to run counter with 2. So then number is going to be equal to 2. It's going to say 2. And then it's going to do it again. Counter number plus 1. Well, what's our number? Number is 2. And then we add 1 to it. What's this? 3. And then the process repeats back, and again, and again, and again. It's going to go back here. 3 is going to get passed through. And this is how it becomes, oh look, it's ready at 37, 38, 39, 40. So this has a lot more uses than just making a simple counter. As I said before, it's used a lot for complicated programs for organizational purposes. But we could add in another element. For example, I can call this the common difference. So instead I can move this here. And then here's what I'm going to do. I'm going to drag the common difference into here. So before, instead of common difference, it was just equal to 1. But now I'm going to move the common difference in there. So if I set this equal to 1, this little guy over here, this second parameter, then 1 is going to be passed through into here, into the common difference, and then this is going to be 1. And unlike the number, the common difference is always going to stay 1 because we're never adding something to it, right? It's just always going to be the same. And I forgot to do this, but we have to move the common difference in here so the common difference stays the same. So if we run this, our program will be exactly the same as before. 1, then 2, then 3, then 4, etc. But what if we make the common difference 5? So now, instead of doing number plus 1, it's going to do the number plus 5. So it becomes 6, then it'll become 11. And the reason why the common difference is always the same is because this 5 is getting passed through to the common difference, and then the common difference is getting passed here and here. On this side, all it's doing is adding itself to the number. That's how we go up by 5. But on this right side over here, it's just going to stay the same. So when we run the function again, the common difference will be the same, no matter what. I hope everybody who watched this tutorial found it useful, because I know that a lot of people have trouble, me and myself included, getting started with making blocks. I found them confusing, and once I finally did understand them, I didn't actually see a purpose for them. The only time, and the first time, I'll admit, where I actually had a true purpose for using these blocks was in my infinite multiplayer base right over here. This is the first time that I made heavy use of these blocks, and honestly, I don't think I would have been able to make the program without these blocks. It would have just been too confusing and complicated, but theoretically, I could have. So I hope this video was beneficial. If you enjoyed it, please like the video. It would help, and leave a comment if you have any questions. Finally, if you want to see more informative Scratch tutorial videos, you can feel free to check out my channel. I have a bunch of videos related to different topics, and if you subscribe to my channel, you'll get notified when I create new videos, and I will be creating new videos in the near future about this Infinite Multiplayer Base V2 once I eventually get it to work. Thank you for watching the video, and have a nice day.